Question 7 is saying, oh, it's about endoscope cable simulation. And the question reads, in a training simulation, a soft dummy is launched at 20 meters per second, 40 degrees above the horizontal from the top of building A towards building B, which is 50 meters away horizontally. The question is, at which vertical position relative to the launch point does it hit building B? So this is a very interesting question. There's a dummy which is traveling between two buildings. We have building number A, or we have building A on the left here, and we have building B on the right here. And they've given us to say the distance between these two buildings, the horizontal distance is 50 meters. They've given us the initial velocity and the launch angle. So what are we going to do in this question? This is a very, 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 very practical, simple question. First, let's get our data. So we've been given our initial velocity to be 20 meters per second. We've also been given the distance between A and B. Say this distance is actually equal to 50 meters. We've been given the launch angle, 40 degrees. And we also know to say there is gravity in this case, which is 9.81 meters per second squared, like this. So what are we going to do? We are supposed, or we need to calculate the vertical position at which, or the vertical position in the y-axis relative to the launch point when the projectile is actually going to reach this 50-meter distance in the horizontal axis. I hope you've understood that. We need the vertical position relative to the launch point when the projectile is actually going to exhaust this 50-meter distance in the x-axis. So first things first, what are we supposed to do? Let's calculate the time that we need in order for this projectile to travel from building A to building B. And which formula are we going to use in order for us to find that information? We're going to say displacement in the x will be equal to what? Will be equal to initial velocity multiplied by time. This is the formula that we've been using. We discard the last part of this equation because we know there's no acceleration in the x-axis. We've already been given the displacement in the x, and this will be equal to the initial velocity. This initial velocity is actually in the x-axis. So what are we going to do? We're going to say 20 cos 40 degrees. This multiplied by the value of time that we're looking for. So we are dividing both sides by 20 cos 40 degrees, even this side by 20 cos 40 degrees. That will cancel out. That means the time it takes this dummy to travel from the top of building A, or the launch point of building A, and hit building B will be equal to 50 divided by 20 cos 40. 50 divided by 20 cos 40. And this is giving me time, which is equal to 3.26 seconds. Okay, so we've calculated the time that this object is taking from the time it is launched at building A until the time it hits building B. So we know to say this is time, and time is applying in both the x and the y axis of motion. So what are we going to do? We can now use this value of time to calculate the vertical displacement that this projectile is going to travel. We're going to use this same value of time to calculate the vertical displacement that this projectile is going to travel before exhausting this time frame that we've calculated. And which formula are we going to use? As simple, we'll use the formula displacement in the y is equal to ut plus half at squared. But initially, this motion is actually going up, or this dam is actually launched up, which means initially it is traveling against the acceleration due to gravity. So we're going to say displacement in the y will be equal to ut minus half at squared, like this. And we can plug in the values. Displacement in the y will be equal to, the initial velocity in the y will be equal to 20 sine 40 degrees multiplied by the time, which is 3.26 minus half 9.81 3.26 squared, like this. If I plug this into my calculator, I'm getting 41.964 minus 52.171, and this is giving me a final answer of negative 10.207 meters. Okay, so this is the final answer. This is the final answer. And what does this mean? That means from the launch point or relative to the launch point on building A, the dummy is going to strike 10.207 meters below that point on building B. So it is going to travel 10.207 meters below the launch point. That's the point where this dummy is actually going to strike building B. So thank you very much, guys. That was the end of tutorial sheet 3. And as usual, I would love to show you something. So if you register us, as you know, next week is a period of mid-semester exams. And we know to say you guys have a new lecture. So we have a lot of past papers that we've solved before on our website or on our mobile app. But your lecturer in the beginning, he emphasized to say you shouldn't dwell so much on past papers. You should attend classes and solve tutorial sheets and make sure you understand the concept. So in or as a way of helping out us as Discrete Learning Institute, what have we done? We've solved all the tutorial sheets on the topics that are coming in your test. It's covering topic 1, topic 2, topic 3, topic 4, and the lab sessions that you've conducted. And we have all the solutions to tutorial sheet 1, 2, 3, and 4 available on our drive. So make sure you go through these tutorial sheets or these tutorial sheet solutions and also go through past papers to make sure you've understood fully the concepts under these units that you covered in class, and also go through the lab. And when you are finished with doing that, I can guarantee you to say you can't fail to answer questions. The logic behind all of this is understanding the concept, understand the basic concepts, understand the main concepts, and you should be able to apply them and not face challenges in your exams. So thank you very much, guys. Register us. The whole procedure of registering is in the description of my YouTube channel, or also the description of this particular video. And you can download our app from Google Play Store if at all you're using an Android phone, or if you are using iOS, you can continue using our website and subscribe to the channel, like this video, and share. Thank you very much. As always, you're with me, Tutor John. Stay blessed.